Activity 6. Sketching quadratic relations. This activity is part of Unit 4, Applications of Quadratic Relations. There are a variety of tools to use to construct a graph of a quadratic relation. Quadratic relations can be expressed in a number of ways. We have our standard form, our factored form, and our vertex form. The graph produced by a quadratic relation is always a parabola. We're going to graph using a table of values. Recall, we're going to graph y equals x squared. We'll set up a table of values. Here it is. For a quadratic function, we have to choose at least 5 x values. Here we'll choose -2, -1, 0, 1, and 2. We'll now calculate the y values. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So when x is -2, y is 4. When x is -1, y is 1. When x is 0, y is 0. When x is 1, y is 1, and when x is 2, y is 4. The second step is to plot the points. So we'll plot each point. -2, 4. -1, 1. 0, 0. 1, 1. And 2, 4. The next thing we do is connect the points. Here it's done with straight lines, but we'll use a curve because a parabola is curved. Let's do an example now. We're going to graph y equals x squared minus 3x minus 4. We're going to follow the same steps that we followed for the previous, more simple y equals x squared. First step is to set up a table of values. We'll use these x values. We'll now solve to find out y. So when x is -2, y is equal to -2 squared minus 3 times -2 minus 4. -2 squared becomes 4. -3 times -2 is +6, and -4 stays the same. 4 plus 6 is 10, minus 4 is 6. So when x is -2, y is 6. For x is equal to -1, we complete the same steps. And when x is -1, y is equal to 0. When x is 0, we follow the steps, substituting zeros in and solving. So when x is 0, y is -4. When x is 1, y is equal to 1 squared minus 3 times 1 minus 4, which is 1 minus 3 minus 4, which is -6. And finally, our last point, when x is when x is 2, y is equal to 2 squared minus 3 times 2 minus 4. So 4 minus 6 minus 4 is -6. Our next step is to plot the points. Our first point is at -2, 6. The next is at -1, 0. The next is at 0, -4. The next is at 1, -6. And the next one is at 2, -6. So the vertex is somewhere between these 2 points, 1, -6, and 2, -6. Symmetry can be used to obtain other points. So we know that a parabola has an axis of symmetry, and it's located at the vertex, so we can just add the points from there. So for example, this point goes to the right once and down twice. So our point after this one would be up twice and over once. We continue the same steps. This is 4 steps up, 1 step over, 4 steps up, 1 step over. And then we connect the points with a curve. Let's try another example. Take a moment and set up a table of values for this quadratic expression, y equals negative x squared plus 5x minus 5.